Okay, welcome back Science 30s to our next lesson in Chapter 5, this 5.7, and today we're going to be looking at power. So previously in the course, we've looked at voltage, current, and resistance, and now we're going to be looking at this new term called power. It's a commonly used word, but what it means in relation to physics is the rate that energy is used. So if we look at this light bulb here, it's going to be using energy, and you may recall from Science 10 and 20 that energy is measured in joules. And so it's using this joules and it's converting electrical energy into light energy, probably some heat as well. But if the amount of energy that it's using is 15 joules, 15 joules, 15 joules, and it's constantly using that much energy every second, we would describe this as its power rating, as 15 watts. And the reason we use watts is watts means joules per second. So it's measured in joules per second, which means watts. Okay, so if this was using a higher amount of energy every second, it would have a higher rate of any energy use, and it would have a higher power rating. Something like 20 watts or 25 watts is using more energy per second than a 15-watt bulb. Okay? And our formula for calculating power is P is equal to W over T. Now this may initially seem like watts, but this W actually stands for work. And you may remember from previous science courses, work is equal to a change in energy. So it's the rate that energy is changing, change of energy divided by time. You might also see it like this, just with this triangle meaning change and E standing for energy as well. That's the format that I like to use most because then it shows energy a little bit more clearly. But again, W is work, and work is equal to a change in energy. Okay, so let's take a look at an example. This one says, how much energy does an 850-watt freezer use when it runs for 6 hours? Okay, we're going to get a big number because 850 watts means it has 850 joules of energy being used every second, and this is going to run for 6 hours. So let's start with our formula. P is equal to change in energy over time. We're trying to find the change in energy, how much energy it uses. So we have to multiply by T on both sides to rearrange for E. So I'll move the T over here. Power times time should give us our change in energy. Now plugging in our numbers, I'm going to put 850 watts, and I have to put my time in seconds because watts, that should be a capital, but watts is joules per second. So I need to multiply this by seconds. So how I did that here is I took 6 hours, and in 1 hour there is 60 minutes, so times by 60 to get minutes. And then in 1 minute there's 60 seconds, so times by 60 again to turn 6 hours into seconds. Now I just put that there in brackets in my calculator, and when I multiply that, I get a large number of 18,360,000 joules. So it's a large amount of energy. And when we get big numbers like this, we can represent it in different ways. We could represent it in scientific notation, where we take the decimal from here and move it over 1, 2, 3, 4, 5, 6, 7 positions. And kind of where my cursor is, we'll write it as 1.836. Just going to round that to 1.8 times 10 to the 7 there. That should be an exponent times 10 to the 7 joules. Another way that we could write this is we could write it in a different unit. So if you put a K in front, it means thousands of joules. If we put a capital M, it means millions of joules. So I could also write it like this. I have 18 million joules, so I could write it as 18 mJ, and this stands for mega joules, which means how many million. Now those are some good units or different ways to write this large number, but we actually have another way for energy, another unit that could represent energy is kilowatt hours. So this is when we have large amounts of energy. So something is using kilowatts, which means thousands of watts, and it's doing it for long periods of time. So we're timing it by hours here. So if I was just going to take that same calculation from before, right, 850 watts times 6 times 60 times 60, that was giving me a number in joules, but since it's going to give such a big number, we could put this in the units of kilowatts. And we're actually going to change our numbers in the calculation here. I'm going to change my 850 watts to 0.85 kilowatts. Now, how did I do that? Well, remember K means 1,000 watts. So I took 850, which I had from before, divide by 1,000, and got 0.85. So it's 0.85 thousand watts. And then when I go to times by our hours, this is looking at kilowatt hours. So I keep that unit in hours, 0.85 kilowatts times 6 hours, and that gives us 5.1 kilowatt hours. So when we're using these big values, it makes sense to use this large unit of kilowatt hours instead of using such big numbers of joules. Okay, so that's one way to look at power, or one description. But we can look at another description of power now relating to volts, as we saw before. So we can relate to the current and the voltage in a circuit. And this formula is going to be power is equal to the current multiplied by the voltage. That's another way to get power if we don't have energy and time. So this next question is saying a 20-watt light bulb runs on two 12-volt batteries connected in parallel. What is the current in the circuit? Okay, a bit of a different question here. First, we'd have to remember from previous lessons that if I have two 12-volt batteries connected in parallel, the voltage of the circuit is going to still be 12 volts. If we need a refresher on that, you can go back to those other videos. Because they're in parallel and they're the same voltage, we just put that as a voltage for the whole circuit. Okay. Now it's relating power, because I see this is a 20-watt light bulb, to current. So I have volts, current, and power. That's going to be using this new equation. So let's set that up first. P is equal to IV. We're trying to solve for the current, which is I. So I'll divide my V on both sides. Power over volts should give me current. Put in 20 watts over 12 volts, and I get 1.67 amps for my current. That's 1.666 repeating, but I just rounded it to 1.67 here. Now, the last formula we're going to look at is what if it asks for resistance? Again, in previous lessons, we looked at voltage, current, and resistance. That last formula had voltage and current, but what if it gives resistance or asks for it? Okay, well, we had P is equal to IV from that last slide, and in other lessons, we saw that V is equal to IR in Ohm's law. So we're going to do a bit of a rearrangement here, kind of a combination of these two formulas, where if V is the same as IR, they're equal to each other, I can put IR wherever I see V. So I'm going to move it over here, and I'm going to put IR instead of V there, since they're equal. And that would give me PI IR. Okay, and I can simplify that a bit because I times I is the same as writing I squared. So here's our new formula now. PIR squared is if it's giving us information about resistance or asking about resistance instead of voltage. So an example could say this: a 25-watt light bulb has 4 ohms of resistance. What is the current through this circuit? Okay, so a 25-watt light bulb with 4 ohms of resistance. We're running that with some battery or some power source. What's the current going to be? We're going to look at this formula, so I'm just going to move that over starting with this. I'm looking for the current, so I have to rearrange for it. This would be one of the harder rearrangements of this course. I would first start by dividing by R, moving it to the other side, so P over R. And then to get the I by itself, I have to get rid of this square, so I'll have to take the square root. So P over R square root is going to look like this. P over R and then square root of that entire thing should give me current. Plugging in my values, I have a 25-watt light bulb, 4 ohms of resistance, 25 over 4 square root should give me 2.5, and the unit there should be amps. Okay, so that's it for this video. We looked at 3 different formulas, all showing here on this slide, all looking at power and just different ways we can solve for power or use power to solve for different variables. So I hope that helped you to complete those practice questions and understand what power is and how to calculate it. Thank you so much for watching this video, and I will see you in the next lesson.